In this video, what we'd like to do is state the amplitude for each of the following sine graphs. So the amplitude is a particular feature of a sine graph, and it is essentially how far above and how far below the sine curve or sine graph would reach from a center position or a middle y value. So luckily, when we're given the rule, we can determine the amplitude relatively easily by looking at the number that multiplies the sine function. Now the little trick here is the amplitude is a distance essentially. So if we have a negative value, as is the case with this -3, we would say that the amplitude is simply +3. So for part A, our amplitude is simply equal to 3. So it's not -3, it's +3. For part B, we once again look at whatever's multiplying the sine function, and it is 1/10. So our amplitude is 1/10. And we could also say that that's 0.1 as a decimal if we wanted to. For part C, we look for the number that's multiplying the sine function, and it is 43. So that means our amplitude is 43. And for our last one, we can see that the number multiplying sine is a negative fraction. So we just take the positive, and it is 3/5. So it's not just the 3 or the 5, it's 3 divided by 5 will be the amplitude. Now that as a decimal would also be exact, and it could be written as 0.6. So what we'll do now is we'll actually go through and sketch a couple of these graphs. And at the end, I'll put any graphs that I don't sketch in. So if we start with A, we have y equals -3 sine of x. So on the CAS calculator, we want to go into the main menu, and then we want to type in -3, and then using the keyboard button, we can find sine, and we're just going to put x in there. And we need to check that our settings are in degrees, and then we're going to hit execute and drag that down into the graph screen. So we've clicked on the graph icon, and now we drag -3 sine of x in, and it doesn't give us a particularly good view of the graph just yet. And what we need to know, and we'll cover this in other videos as well if you haven't seen it already, is that the period or the length of sort of one cycle of a sine graph is 360 degrees unless it's been changed. So because all of these are just sine of x, sine of x, sine of x, and sine of x, we want to click on these 4 arrows, and we want to change the x minimum to be 0. That's where we'll start our graphs. And we want to change our x maximum to be 360. And because the amplitude's 3, going between -4.6 and 4.6 is fine. So I'm going to hit OK, and that now gives us a much better look at the graph. And if I go Analysis, Gsolve, and we click maybe Maximum to start with, we can see we've got a maximum here that is going to be at 273. And hitting the blue Execute button on the keyboard will lock that on so we can refer to it later. If we go Analysis, Gsolve, Min for our next one, we're going to find that there is a minimum at 90, -3. And again, we can lock that point on by hitting Execute if we want. So we can see, based on this graph from the calculator, that the function does go 3 above the middle, which is y equals 0 for this graph, and it also goes 3 below. So that's why we say the amplitude is 3. So now if we have a go at doing the same thing for B, we're going to want to type back into the main area of the calculator, using keyboard and a fraction to start with, 1/10 times sine of x. And we can drag that now into our graph screen. So that will sketch what looks like a straight line on the screen. What that means is we need to think about how we need to change the graphing window so that it will display better. So using the 4 arrows or things at the top of the screen, we're going to change our x minimum to be 0 and our x maximum to be 360, because we talked briefly before about that being one cycle of a sine graph, provided the number next to the x hasn't changed. And the y minimum and the y maximum, instead of going from -4.6 to 4.6 or something like that, we want it to be a little bit closer to 0.1. So I'm going to have a little bit of room above and below, so I'm going to pick -0.2 to be the minimum y value, and +0.2 to be the y maximum value. then we can hit OK, and it will give us a much better look at this graph. So analysis G-solve max, if we do that one first, will give us a maximum at 90, 0.1. So that 0.1 is based around this amplitude value. And if we go analysis G-solve min, we'll find that that is going to be a coordinate of 270, negative 0.1. So again, that amplitude's how far above and how far below the center y value, which is at y equals 0, this function reaches. So I won't go through the next two using the calculator fully, but I will put the CAS screens just over here as you can see. So you can see that the amplitude for this one is 43, and it goes 43 above and 43 below that center line. And this one here, the amplitude is 0.6 because it has a maximum of 0.6 above and a minimum of 0.6, or sorry, negative 0.6, which is below that center line. So hopefully this video has helped you understand how we can find the amplitude, particularly if we're given the rule. We just need to look at that number that's multiplying the sine, or in a later video we'll see the cosine function also has an amplitude associated with it. So good luck for the questions that you're about to attempt, and stick around for more videos that will go over the period, amplitude, and that for cosine as well.